You've spent the last 3 lessons observing the physical world. By now, those individual observations are ready to be viewed as a single, cohesive picture. We started with matter, anything that has weight and occupies space. Then we looked at transformations, the process of matter changing its state or becoming a new material entirely. Finally, we followed the energy, the force that enters or exits whenever those physical changes occur. Chemistry is the study of how these 3 things interact, what matter is made of, how it transforms, and the energy involved in every change. This definition summarizes the practical work you've been doing. It's a formal name for a way of looking at the world that you've already begun to master. For many adults returning to school, chemistry carries a reputation for being an endless list of formulas to memorize and strange names to recite. Think of a formula as sheet music. The paper isn't the music, the sound is. In the same way, the formulas are just the notation. The actual chemistry is the physical world in motion. If you have ever cooked a meal, laundered clothes, or mixed concrete, you have already managed matter and energy thousands of times. Your life experience is an academic asset. You are simply putting names to processes you already handle in your daily life. Marketing often uses the phrase chemical-free to suggest a product is safer or more natural. This is a logical impossibility. Everything physical is made of chemical substances. Rainwater, the oxygen in your lungs, and the sugar in a piece of fruit are all chemicals. These salt pans produce a substance that is entirely natural and harvested directly from the environment. It is also a pure chemical. When people express concern about chemicals, they are usually referring to synthetic additives, pesticide residues, or industrial pollutants. Using the word chemistry as a synonym for poison makes it harder to understand how the material world actually works. Relying on vague vocabulary creates the false impression that anything found in nature is inherently safe. Rattlesnake venom is entirely natural, as are many lethal toxins found in wild plants and fungi. The opposite is also true. Being artificial does not make a substance inherently dangerous. Safety depends on the specific substance, the dose, and how it is used. At high enough levels, even water is toxic. In the right dose, a toxin can be a life-saving medicine. Chemistry provides the criteria to look past labels and make informed decisions based on evidence. Vaccines are a clear example of how engineered chemistry preserves human life. Massive public health efforts used these lab-developed substances to eliminate diseases like smallpox and polio, which had paralyzed and killed people for centuries. We saw this process repeat recently, as global laboratories developed new defenses to protect the population and allow society to reopen. A vaccine works by showing the body's defenses a harmless piece of a virus. This allows the immune system to learn to recognize the threat before a real infection occurs. You can see these principles in your own backyard, an iron gate rusting in the humidity, or the carbon dioxide you exhale with every breath. Chemistry is a tool that gives you the capacity to understand and master the physical world you live in every day.